Good morning. Like to thank the organizers for organizing this very interesting event and for inviting me here to participate. It's been wonderful. Can the people in the back hear me? Okay. If at some point you stop being able to hear me, just make some sort of motion and I'll speak up. So I'm going to talk today about something a little bit different. We have had, not surprisingly, several different talks in this series about the processes of reasoning. How is it that people come to generate or fail to generate a conclusion? And what I'm going to talk about today is a different kind of approach to understanding reasoning. And that is a metacognitive approach on how we monitor, that is, we assess or evaluate our thinking, and how that monitoring changes or doesn't change our thinking behavior. So that's the basic framework that I'm going to be talking about. I'm just going to allow you to imagine whatever underlying reasoning process you feel most comfortable with, and we can put a metacognitive analysis on top of that. So I'm going to start here by talking just a little bit about metacognition, because I think when I say metacognition, people have this kind of an image, right? Metacognition is a very reflective, thinking about your own thinking kind of approach. It is deep and profound. You can modify your thinking by doing this. And I'm not arguing that we can't. I'm just saying that's not likely what it is that people do metacognitively most of the time. And in fact, the analogy I would probably prefer is something like this. This is a thermostat, if it's not clear in the back. It's in North America, at least, we have central heating, and you can't have the heating on all of the time. So you have a thermostat, which is a device that used to be filled with mercury. They fill it with something else these days. But that when the temperature in the house drops below a certain level, it sends a signal to the thermostat, to the furnace, and the furnace comes on and starts to heat the house. Okay, so in the language of metacognition, the thermostat is monitoring and then initiates control, which is to turn the furnace on or to turn the furnace off when the temperature is reached. But this is a very passive sort of monitoring, right? This is monitoring in response to a very simple cue, which would be a change in pressure to one of the diodes inside the device. The other point I'd like to make about monitoring is that, in line with this idea that it's very low level, low key, low demanding, that it's mostly based on cues that are available to the reasoner in the environment. And the analogy I've got here is a smartwatch. I have a smartwatch. One of the things my smartwatch tells me every day is how many steps I've taken. But hold on here, the smartwatch is attached to my wrist. How can it possibly tell me how many steps I take in a day? Well, the smartwatch is using a cue. The cue is something like this, like the movement of my arm that when I am walking, right? So when I walk, I move my arms. And in fact, when I'm in when I'm in an airport and I got my suitcase on my roller, walking like this, it thinks I've been sitting still. It makes me really frustrated. But the idea here that these kinds of monitoring cues work well some of the time and not so well at other times, so that they can be misleading. And so if we go back to that set of relationships that I was talking about, if the monitoring is based on a misleading cue, so will then the control processes be misaligned. We also know from lots and lots of research that this leads to the situation where people can be confidently wrong and uncertainly correct, right? So that you get both kinds of undesirable outcomes because their confidence is not based on their performance, It's based on whatever cues have been available to them to make those judgments. Okay. So I'm going to, yes, a little image here, and the motivation for this, I'm not quite sure why. Let's take there. If I see clearly, it's because I stand on the shoulders of giants. But what happens when you fall off? And gravity takes its inevitable course. And now we've got this poor person on the ground there trying to reconstruct the clarity of those paths that he saw. So that is cognition. The metacognition comes in here. Like, which of those paths was the best path, right? And so that uncertainty is a signal that it's a metacognitive signal that we don't know what the answer is, and we need to do a little bit more reflection. Okay, so that in a nutshell is the content of the talk I'm going to give today. Now, I was prompted by Gord's question yesterday about what's going to happen in the next 10 years to go back and see what had happened in the last 10 years. So I went and looked at the slides that I presented to this group 10 years ago. And I think this slide represents the thing that has most changed about my thinking in those 10 years. At first, I and many other people, this is comes grounded in the tradition of Kahneman and Tversky and the dual process theories that Lyndon talked about at length yesterday. The idea that we are cognitive misers, they're kind of lazy thinkers, right? And all the heuristics and biases, research shows that there are simple answers that people could come to, but fail to. Okay. And when I started this research, it was with that model in mind. And so the question that I asked was, well, what makes us think? What gets us started thinking? And I'm going to do a brief overview of that, this summary from that work. But the question I'm going to end with and spend most time talking about today is this one. This is also a meme that we have about effort, right? And it's don't give up. Believe in yourself. Be true to yourself. Stick to it. Be persistent. Oh, this is the basis of all sorts of self-help stuff and motivational work and movies and everything, right? So it is a good thing to be persistent, to not give up. But these two things are in direct opposition to each other, right? The one model suggests that we're lazy and we're reluctant to engage. And this one is, well, once you're engaged, keep going and don't surrender. So how do we reconcile these two metaphors? I'm going to start by talking about the cognitive miser. As I said, that's where my work was grounded. It was really based on the sorts of dual process theories that have been discussed yesterday. And the idea at some point that people have to switch from system 1 to system 2 kinds of thinking. And so what is it that gets people to make that switch? So this is a typical kind of problem that we bedevil participants with. I've changed it up some from the bat and the ball type problem, but it's an example of that kind of problem. And the trick here is that people fail to consider that the whole length of the train, all 500 meters of it, has to move through the 500-meter. So it moves farther than you think. So in this context, thinking is a control action. And when you put it in the framework of a metacognition, it's so what kind of monitoring are we doing that triggers the control action of thinking, of type 2 thinking? And Maggie Toplak this afternoon will likely talk to us about her perspective, which is one based on individual differences. I'm going to talk about a different perspective, which is one based on situational or item-based local differences in. The initial investigation involved developing this two response paradigm. I'm just going to run you through that really quickly. We give people problems like this, belief bias problems. They're asked to make a judgment quickly. Sometimes we put them under time pressure. Sometimes we always ask them, did they respond with the first thing that came to mind? And then what we do that's a little bit different here is we ask people at that time, what did that answer feel like to them? So this is a way of assessing monitoring, like how do you feel about the answer that you just gave? And at the time that we started, it was just a Likert scale. You can use any kind of scale you want here, 0 to 100. So they give a first answer. They tell us what their feeling of rightness is. We take that as a measure of monitoring. We also measure the speed or the ease with which the answer comes to mind. And this is one of the most reliable cues to feeling of rightness. That is, things that come to mind quickly or easily feel right, regardless of whether they are right. So among the many cues to feeling of rightness, this one is very reliable. We then give them the problem a second time. They're allowed as much time as they like to think about it. And here we get the measures of control. So how long did they actually spend thinking about it? And did the answer change? Was there evidence that this was not the ruminative sort of reflection that Janie described, but the one that was attempting a reanalysis? Okay. And then I'm just going to give you one set of data for this because we've observed this kind of pattern in many different kinds of tasks and many different kinds of situations. This is data from a classic waste and selection task that we published quite a few years ago. What we did, I'm trying to get there we go. We just binned all the responses where FOR was equal to 1 on that 7-point scale. 2, 3, 4, 5, 6, 7. So 1 is it didn't feel very right. And here 7 is I'm certain I'm right. And we plotted the time it takes to give the first answer. So this is fluency. And you can see here there's a lovely straight line. Answers that didn't feel right took longer. Answers that felt right were shorter. Okay. RT2 is the open circles. And this is the amount of time people spent rethinking. So when their first answer didn't feel right, they spent more time rethinking. Until it was 7, they spent virtually no time. And this one with the squares is on this axis here. It's the probability that they change their answers. Okay, again, from quite probable to not at all. So 3 things. So monitoring is a process based on cues. One of the cues is fluency. Things that come to mind quickly are a signal to be confident. And this in turn produces feelings of rightness, which in turn predict the control behaviors that follow. So that's pretty much a summary of that early work. So one answer to what makes us think is that we feeling of rightness and where the feeling of rightness comes from. If it's strong, we stop. If it's weak, think. Regardless, however much we think, and this is something that Wim told us about yesterday, 90% of the time, we end up with the answer we gave the first time anyways. Most of them, depending on the paradigm you're using. It's quite usual that people don't do a lot of answer changing in the interview. Okay. Been through all this. Okay. So I'm going to start now on some new work. And this is going to take us down the other path about the path to persistence. But it begins in the same spirit of that work. So what makes us start to think? So I was talking about a situation where people rethink, but there's all sorts of situations where you have to decide whether you're going to engage with a problem or not. So here's my example. Went shopping, needed a new desk. Went to the store, saw the desk, said, fine, here's my address, ship it to me. And when it arrives, this is what happens. Me, I look at this box and I say, wait, that's like, 3 days or 4 days of my life that I'll never get back. I'm not even gonna try. My friend Megan comes over and looks at the box and said, well, give me a glass of wine and a screwdriver and I'll have it done for you in a couple of hours. Bargain. So the monitoring judgment that we're going to talk about here is this initial assessment of what we call judgments of difficulty or judgments of solvability. They're slightly different. I'm going to talk about both of them kind of interchangeably. So my judgment of solvability was, I can't solve this problem. Her judgment of solvability was, oh yeah, I can solve this problem. Her judgment of difficulty is, give me a glass of wine and a screwdriver and we'll be done in a couple of hours. And the hypothesis is that this is a monitoring judgment, this initial judgment, that regulates effort, that regulates how much effort you are willing to put into a task afterwards. So to study this, we use a modified to-response paradigm where we give people a reasoning problem with a very brief exposure. Really just about enough time to read the content. Then we ask them for either a judgment of solvability or judgment of difficulty and give them as much time as they want. They have to solve it. And we're going to use the judgments of solvability and difficulty to try and track their subsequent behavior. So these are some data that I'm writing the final draft of. We gave people problems, series problems like this. There were 3 different kinds of problems. What is the next number in the series? Some of these were solvable and some of these were not. So if you switch the 16 to be at 17, you change the series so that there's no correct answer. Same 2 response procedures I described. Participants in the study were given incentives. So you got a bonus if you got the answer right, you got a penalty if you got the answer wrong, and nothing happened if you just gave up or passed the next problem. So we replicated one of the most mysterious findings in the literature, which, despite a brief exposure, people are good at identifying or discriminating solvable from unsolvable. Not 100%, not like that, but reliably different. So they say, yes, it's solvable more often when the problem is actually solvable than when it's unsolvable. Our interest here was in did it predict time solving. And you can see we've got this kind of complicated 3-way interaction going here. So when the problems are solvable, when people said they thought the problems were solvable, which is the red line, they solved them quickly and got them correct. Now, what was of interest to me here is what's happening over here in the unsolvable box. So here the problems were unsolvable. There were no correct solutions to these problems. But when they thought they were solvable, the red lines, people spent a long time, persisted on that problem a long time before identifying it as unsolvable. And this was kind of intriguing to me. And it's the motivation for the rest of the analyses that come. And it makes me think about, we've asked now, what makes us start thinking? What makes us stop thinking? And here I go to think about things like the sunk cost fallacy. Those of you who are old enough in the room will remember the Concorde, supersonic jet flying from New York to London or Paris, built at enormous expense. And in fact, halfway through the project, it was clear that they were never going to be able to recoup the cost of building these jets. That their tickets were going to be so expensive and they couldn't fly them long enough to actually get the investment back. But so what did they do? They kept building. And this is the sunk cost fallacy, in which you continue to work on a project even past the point at which there's no possibility of a positive return. There's another phenomenon that's related, that's called laboring in vain. And we've all done this, where you continue to work on something like, beyond the point at which you're usefully spending your time. So like the 55th time you proofread the manuscript, you're probably not gaining very much for the time that you've spent. But being perfectionists, I think we tend to do that quite a bit. And so that made me think about, well, let's think about giving up. So we don't really study giving up. We don't even give people the option to give up most of the time, even though that's a really salient one that they've got in the world. We give people 2 alternative forced choice tasks or 4 alternative forced choice tasks or something like this, and they have to pick an answer. We know a little bit about giving up. Like I said, it hasn't been studied very often. We know that people don't do it. Whoops. It's a minority behavior, even on difficult tasks. And I'm going to show you some data from the same study, the one that we just saw about from Law et al. So it's the same study here. And what we've got here is plotted, how long did they take before they gave up? And for me, the part of the graph that I'm interested in here is when they thought the problem was solvable. It took them longer to give up, regardless of whether it was solvable. So for both solvable and unsolvable problems, when they thought the problem was solvable, they persisted. Okay. Now, in this case, the persistence might get you the correct answer, although it didn't. They just took a long time before they moved on to the next problem. But here, you're never going to get the right answer because there isn't one. Right? So like, this is clearly a laboring in vain situation. Now, these are even more fun. This is how long it took people to come to the wrong answer. Okay, so they could type in, they had eight answers, so they could like say, I choose one of these or I give up. Right? And in every case, for every type of wrong answer that was possible, they spent longer giving it when they thought it was solvable than when it wasn't. So clearly, I think this initial judgment of solvability is a monitoring cue that actually guides subsequent control behavior. In this case, how long people are willing to spend on a problem before taking action. Okay, so we've talked now a little bit about judgments of solvability. There's a little bit of literature that shows that, like feeling of rightness, and confidence and other monitoring variables, judgments of sensibility are subject to surface cues, misleading cues, and we'll talk about that in a minute. And like I said, actual solvability. And to me, this is a complete mystery. Like, how are people, if it was just like for one kind of problem, that would be one thing. We had 3 different kinds of problems in the experiment I showed you. It's been done with anagrams. It's been done with the one where you have to find the third word that fills a series. It's been with a whole bunch of different types. So it's not just one type of reasoning problem that it happens. So this is marked down in my book as a mystery that warrants further investigation. Okay. And so anyways, what I want to start now is a series of studies on anagrams, where we're looking at the relationship between the cues that people rely on to make the judgments. And in the best possible world, in trying to establish a causal relationship, you show that the cues affect people's judgments. You show that the judgments then predict. in a systematic way, people's behavior. So you change one thing, and then it's an effect on other things. Okay, this one I've included more as a object lesson than anything else. We set out here to do a very ambitious study on anagrams. This is a team of researchers that includes Zuleika and some honor students in the lab. The task itself is very simple. It's an anagram. So you get a series of letters. These were all 5-letter ones in this case, like DNSP, and you're supposed to unscramble them and come up with the word spend. Okay. Same two response procedure that I'm talking about. We gave people 3 options. They could give the answer if they got the solution. They could say it was unsolvable, or they could give up. And again, the incentive structure was, well, if you got it right, either by correctly identifying unsolvable anagrams or by giving the correct answer, you got points. We took points away if you got it wrong, and passing was neutral. Now, this, yes.
Do they know that some of the problems are unsolved?
They do. That was even a variable in this experiment that worked out a little bit weirdly, but for one set of problems, we told them that many were unsolvable, and a few of them were unsolvable, but in any case, they knew there were going to be unsolvable ones in the mix. Yeah. Well, less than 20% of the trials were given up on. And this, from an analysis point of view, is a real pain to deal with, because if you have a factorial experiment where you're trying to, this was a 2x3x2 design, right? If you've got 80% of your trials missing, you never fill all the cells in your design. So you end up basically with no data to analyze. But we did learn a couple of things. One, saying unsolvable, giving up was unpopular, but saying unsolvable, that was a good option. So if you gave people the option to say it was unsolvable, then they would do that and take a chance at being wrong rather than give up. Okay? And we did learn a few useful things, at least on a correlational level, that people's initial judgments of solvability was correlated as predicted with time to give up, just as I showed you in the previous slide. But took them longer to say unsolvable, and they made more attempts at solutions. So because they were typing the answers as a free response, we could track how many times they had typed in a wrong answer before they got to a right answer. So on this level, at least the judgment of solvability does appear to be predicting how people engage with the problem. But we need to get this number off the floor. So, final set of data I'd like to talk with you about today is one. This is just hot off the press, actually. Very hot, it's still smoking. And this is part of Zuleika Gazimov's PhD. We have now one of the people in our lab has developed a database not only for anagrams, but would be useful for anybody who's doing any research with words. You can figure out how frequent the word is, how dense its semantic neighborhood is, does the spelling of it respect the normal rules of English. There's just a whole suite of variables in there that we know are likely to be relevant to people's ability to find words. We used pronounceable and unpronounceable anagrams. So pronounceability is a misleading cue. If you give people something that's pronounceable, like these two here, right? Those look easier to solve than these two over here. But in fact, these two over here are easier than these two. So pronounceability is a misleading cue. So we've got pronounceability and then word length. So some of them were 5 and some of them were 6. And 6 is an accurate cue. That is, 6-letter anagrams are harder to solve than 5-letter anagrams. we controlled a whole bunch of other things that we think might affect performance. And we used the same two-response procedure as I've described before, except this time, instead of judgments of solvability, we're collecting judgments of difficulty. All of the anagrams were solvable in this case, and they were not given the option to choose unsolvable. So they could either solve the anagram or give up, basically. On this procedure, we now have more than 60% of the trials where people give up, which gives us some ability to actually do the analysis that we want. Okay, so do surface cues affect judgments of difficulty? These are collected on a scale of 0 to 100. And the effects look small, but they're very reliable. As we expected, people judged the pronounceable items to be easier than the unpronounceable items, and the longer words to be more difficult than the shorter words. So what we should then expect based on this is that people relying on their judgments of difficulty are going to persist longer with the unsolvable, going to persist longer with the easier anagrams and less time with the 6-letter words. Okay, this is just how they did on the task, predictors of solvability, and you can see both pronounceability and length had the expected effects. Easier to pronounce and longer anagrams were solved less often. Anagrams that were perceived as difficult were solved less often. And this is the sort of analysis is that the judgments of difficulty have their effect even after parceling out the actual difficulty of the anagrams. And people did poor on the task as time went on. Okay, but here's the data that we're most interested in, and this is really what we were looking for. Easy to pronounce anagrams took longer to abandon. So if you initially judged it to be solvable, easy to pronounce anagrams took longer to abandon. 6-letter longer anagrams were also abandoned more quickly. So judgments of difficulty were affected by the surface cues, and in turn, this translated to how long it took people to give up on the problem. And again, even after taking that variance out, judgments of difficulty in and of themselves predicted how long it took before giving up on a problem. Okay. And I think that's the last slide, is this one showing the relationship between judgments of difficulty and time to give up. We finished early. I took up a whole bunch of slides because I was afraid we were going to run over time, but here I am early. Okay, so let's put this all back together. So this is the original meta reasoning model that Rafat Ackerman and I developed in 2017 for trends in cognitive science. And as I said at the time, I was mostly thinking about a dual process sort of model of reasoning, where people might give an autonomous response, then do some analytic thinking. The idea that we wanted to stress was that monitoring is not just a one and done kind of process. It continues throughout the course of reasoning with various different kinds of ways that we can have to measure or try to access those monitoring. And the reason that's important to understand monitoring is because of this relationship here between monitoring and control. And so today I've focused on initial judgments of solvability and whether or not people engage in solving, and most importantly, how long it takes them to disengage in solving. Or the feeling of rightness. Do people provide the initial answer? Do they think about it? And then Rafat has done a lot of work on intermediate confidence, looking at how that changes over time and basically what happens is as time goes on, the confidence, the threshold required to give an answer goes down. So, and if you start out, you won't give an answer until you're about 80% sure. After a few minutes, 20 or 30% sure is fine. And interestingly, giving up is the very, very last thing that people will consider. Monitoring, in sum, is inferential and based on cues. And the cues that people use are not always aligned with objective accuracy or difficulty. To the extent that cues are or well calibrated, then so too are the accompanying control processes. Okay, so if the problem is solvable and you think it's solvable, then that is a good cue. If you think the problem is solvable and it's not, well, you're spending your time, you're wasting your effort on something there. And as a result of these misaligned cues, people may fail to rethink incorrect answers or fail also to act on good ones. I've demonstrated many cases where people labor in vain. The amount of time people take to give up, the amount of time people take to give wrong answers, right, is predicted by their initial assessment of whether or not the problem is solvable. And in a perfect world, people would quickly identify which problems they can solve and which ones they can't, solve the ones they can, and just not waste any time messing around with the ones they can. And paradoxically, it is both difficult to get people to start thinking and to get people to stop. The only time we have give up rates in over 50% is when they've got no other option. If you give them any other option, like call the problem unsolvable, they'll take it, right? It was only when they only had the option to either solve the problem or give up that we see a lot of give up behavior tasks. Okay, that's me, I'm finished.
I have a question.
Okay, go ahead.
Do you think we might explain our tendency to not give up despite setbacks through an evolutionary lens? Perhaps a piece of this puzzle lies encoded in our genes shaped by natural selection. In harsh environments, and activity might have been worse than attempting and failing. And could this also have affected our monitoring cues like judgment and so on?
If I think about this in an evolutionary perspective, there are lots of ways in which people conserve energy, right? So that's sort of a basic thing, that you don't expend energy if it's not needed. So from that point of view, I think it's easier to explain people's reluctance to engage thinking, and possibly more difficult to explain why they don't disengage when they ought to. Yeah, Courtney.
This relates to what you said. I mean, in a certain sense, I think it's almost certainly the case that you're also underestimating how much people would give up, because in this kind of scenario where people are being compensated to participate, it's in a certain sense kind of illogical to persist, because it's coming at economic cost, or like it's opportunity cost. They should be, economists would look at it and think, why are they doing it at all? Why, if you have the option to not do it, why are you doing extra mental work when you would get compensated the same amount one way or the other? So I guess one question I have is for like, what do you think? I know there's like moving away from the like features of the problem, but what is it that's leading people to actually like persist beyond just like what they think about the problem? Is it like it's impolite to not do it? Are they is it social pressure? Is it like they don't want to feel like they can't do it? Are they overconfident? Or like they, is there speculate freely about all the other possible things?
So a set of data that I didn't talk about, just Rackifed is just had accepted in this study, the incentive structure was designed so that giving up was the best option. So that you only ever got penalized. So you didn't get rewarded if you were right. You were penalized if you were wrong, and you got a free ride. So you would keep all of your money by just giving up on every problem. And the giving up rate, 24%. So, you know, even when the incentives are really skewed towards give up as the best option, people don't do it. And so therefore, I think we need to now start to think about this, the sorts of things that you're talking about. So what is it? I mean, we even go so far as not to use the words give up. Like we don't say anything about give up. We say pass. You can just pass to the next problem or move on to the next problem, right? We've tried to take that stigma out of it. And even when we did that in the first study I showed you, the giving up rates were still, you know, pretty much on the floor. So I don't know. You know, I'm, you know, one of the things that we've been talking about, like this is a really loose metaphor, and I'm not really sure how to firm it up yet in operational terms, is that we might be thinking about some kind of cognitive inertia. So it might be difficult to get people to start thinking because inertia carries them in the mode where they are. And my colleague Norbert Schwartz has a really good description of this. Is like we just go along, just nod along, till something wakes us up, right? So the default mode is just to keep going along, not questioning, not until something surprising or disfluent or gets us out of that mode. So the initial inertia is to not engage with thinking. But then once the thinking is engaged, maybe there's also some inertia to keeping you in that problem space. This I know is a very loose and very descriptive way of framing it, but it's kind of how I'm thinking. I think Wim and then Ruth and then Beth.
I get the idea. It's reasonable, so you have this initial judgment of suitability mechanisms, intuitive, automatic, and that predicts how long that we're going to keep on trying. But then the final decision actually stop thinking. So what I'm wondering, like, is the decision to stop thinking actually, does that require thinking? Do you think that the final decision is in itself being deliberate, or is that also just like automatic? Is it something because there's like diminishing returns or something like so? What are your thoughts? Like,
Yeah, no, that's a really good question. I don't know. Rakefet's work shows that people, as do ours, that people tend to take a long time and would prefer to give an answer with really low confidence rather than actually give up. So perhaps, you know, that is a constant, a conscious sort of thought. I don't know, but you know, the other side of this is there are always some kind of stopping room, right? That there comes a point in any task where you just have to, for whatever reason, stop working on it now, right? And is that a conscious decision? Yeah, probably, maybe. I mean, it's worth talking about. It's worth thinking about.
I get you're using this paradigm, but then maybe from like an ecological validity point of view, of course, like what about tasks where we do not know, where it's like, let's say like a scientific question, like do we keep on pursuing like a certain like research or like in, I don't know, like you're a company like developing like a product, like in cases where we're just not sure. So that the reason that we're not giving up might be because it's often useful or
So
is that.
So I think this is actually something that we could study in the lab. So the difference between sort of open-ended and closed problems. So these are problems that all have solutions or that people know are unsolvable, right? Many times in the world, we don't know which of these worlds we're in. Like, are we in a world where if I stick to it, I'm going to get to a good place? Or am I in a world where I stick to it, I'm just going to waste a whole bunch of time getting there? And it's pretty much impossible to know the difference, but we can design problems in the lab that have these features. and look at them that way. I think that was Ruth next.
Thanks, Valerie. Really intriguing phenomena, particularly the judgments of solvability. And I was wondering what is going on there? What are people basing those judgments on? And I was reminded of Kahneman and Tversky's original studies of their version of these studies, where they gave people anagrams, easy ones and difficult ones. They gave them 2 or 3 seconds to say whether they thought they could solve them, how many words they would be able to create. And then they gave them the 2 minutes, 3 minutes to actually try and create them. And there was a really good correlation. People in those 2 or 3 seconds were well able to say, for the easy ones, that they'd be able to generate 6 or 8 words or whatever, and for the difficult ones that they'd only be able to generate 1 or 2. So very high correlations there between those initial judgments and their actual solvability. And what Kahneman and Tversky developed out of that, what they said was going on was this availability heuristic that people are sampling, that they're trying to do the task really very rapidly. They're obviously not creating all 8 answers to it, but the ease with which they were able to generate one makes them know that they're going to be able to do this task. And that notion then has been developed by people like Jonathan Phillips and Joshua Nobe and others currently as this idea of default possibilities that we have, that we are attempting to just sample through perhaps norms, perhaps templates of things that we have easy access to. And I just wondered what your thoughts are then in terms of the judgments of solvability that you're seeing. What kinds of things do you think people are taking into account? Is it availability? Is it sampling over possibilities? What are they basing those judgments on?
It's a real mystery because we use anagrams that have only one solution. So if they were sampling from availability, they get the answer right. And then we always do a check. So like right after they've seen it for the first exposure, yeah, I'm coming. But we always do a check, say, did you get the answer right? So it can't in this case be something like that, but it's not much different from the sort of logical intuitions, I think, that Wim has been talking about, that people are picking up on some cue that is reliable, or at least, correlated with the problems being solvable. And we haven't worked out what it is. And it like I said, it's not unique to anagrams. Like you get the same effect in Raven's matrices, right? They go in whatever sorts of problems that you've defined, that people are picking up on some kind of a cue that would be correlated with actual solvability. And I don't know what it is.
So in Korean, I hope that it seems to have emerged from it is that there is this energy in terms of the psychic energy in which we do not give up on a problem. As Melacanation, Arthur can sense that they predict that we may have to continue in the future to use for the next question, so we do not give up. Like you said, like metaphor of a car, you do not stop and start your car, it costs too much energy. But then it also points out the question of long-term projects. It was more of a short-term projects. It was a very sequential problems and anagrams. But then when we talk about the more large projects, as the cardinals, projects, there is a time that you can rest. That there's a time that you can say, do we stop? So there is a similar contradiction here between the short-term use connection and long-term projects.
I'm not sure there is, because one of the thoughts I've had about why people are kind of reluctant to give up is that you don't know what comes next. So if I give up on this problem, how difficult is the next problem going to be? Is it going to be worse? Right. And maybe what's familiar seems better. And I think this is the same in working on projects. You get an awful lot invested in a project that's familiar. You know what the parameters are, et cetera, et cetera. We know task switching incurs mental costs. And could this just be like a task switching kind of effect? I don't know. It's on the deck for being looked at.
You contrasted your work at the beginning of your talk with work on individual differences. But do you think it might be an interesting next step to try and figure out who are those people who do give up? Like this 25% people who do give up. Could they be higher on the scale of need for recognition. Like, if you have a better time doing it, you might need longer to feel like, oh, you want to give up. Or maybe a measure of relationship between ego and cognition as a subjective. It's been raised in protection about giving up. It's part of the ego. Do you think it's where this could be going?
In fact, we have just submitted a chapter to the handbook of rationality, not rationality, intelligence, in which we try to do just this, is to say, take Toplak and Stanovich's framework of actively open-minded thinking and try to bridge that to a feeling of rightness and judgments of solvability. And so can we look at this both from a trial by trial frame and an individual lens frame? And what would it take to say, think about the relationship between AOT and giving up? So one thing you might think of is AOT, people high in AOT might just persist longer generally. The question is, does that mean that they are more likely to judge something as less solvable? Are they more or less responsive to their judgments of solvability? Do they have a different threshold for where, after they've set the judgment of solvability, where the control behavior kicks in? So I think there's lots of different ways that we can go with that. If anybody's interested, I can just send them a copy. Yeah.
Line between speech and brain processing. So one comment is, even Kahneman used to say that we are lazy, and this is just a general comment. I don't think we are, as human beings, lazy. I think the brain is economical. When you're not required to do anything, when the salience network is not being stimulated, DMN does a lot of work and uses a lot of energy and glucose, and it is economical towards what's being required for the outside world. So I don't think we're lazy, we're economical. That's just a the time spent. Have you ever thought you're considered time spent trying to resolve, putting more time, effort in? Is we have this tendency to not want to communicate negative, to say that something is unsolvable, and we'll double check that in many circumstances in life, and a reluctancy to give negative feedback, as they're told that even though it's a pass, but we have that reluctancy, and then giving up is also related to a sense of failure. And when you get to the point, which I find interesting, where people, instead of giving up, will go to a probabilistic approach, is when you think of a chimp has 30% of chance of resolving a problem, why not just go to a probabilistic and maybe I'll hit it right, as opposed to giving up. Even though I have a loss in the context of the lab. It's not like I have a loss like my puppy is gonna die. So the consequences of what my loss is also mitigate what I'm willing to bid on taking a chance at maybe being right and not giving up and taking a probabilistic approach, possibly.
Possibly,
How large are the stakes when you're in a lab context as opposed to real life? And therefore, well, let me take a chance. I might keep the bucket right, because I might get it right.
yeah, no, I mean, that's always a question, right? And they don't let us kill people's puppies. Well, I guess the question, are people still going to show this persistence in cases where there's more to gain? And the opening examples suggest yes, like the Concorde, right? How many times do we use as an excuse to send men and women to die in war, well, to justify the sacrifice of those who have already died, right? Which is a complete fallacy. But You know, but it's a way of continuing the effort at great cost. In some cases, so I know these are like two examples, but they suggest to me that this sort of persistence, this maladaptive persistence, is going to be observed even in high stakes environments.
A lot of work based on self-efficacy and persistence on tasks. How would you integrate this?
So the person to talk about that is Zuleika. That's her PhD thesis. And so maybe at lunch you could, yeah.
What's the answer to the question is how self-efficacy?
Yes, integrated.
We have been thinking about looking into that variable as well as basically like would be a monitoring of how much time you need to succeed if you continue to spending more time on the task, but we don't have any empirical results on that variable yet. So yes, next steps.
How would you guess? Would it be independent of the judgment solvability or set dimension?
Not quite sure, but I think it would be if it makes sense that it would be predictive of how long we'll continue to spend time. So if they think they're getting closer to an answer or they have a higher chance of getting the answer by to spend more time.
I mean, this is an important point because as my colleague Rapid pointed out, like we talk about these cues as being cues derived from this narrow task domain, but of course people bring with them all sorts of other beliefs about, you know, for example, am I good at solving these types of problems? Is this interesting to me? Do I have self-efficacy in this task? As well as, you know, time constraints, right? So like there's all sorts of other variables that are going to influence how people evaluate or make those judgments of difficulty/solvability. Okay, Ruth, then work.
Just in relation to that last point, which I think is a really interesting question, I was also curious about whether there are particular problems that you have different judgments about. So Janet Metcalfe's studies on metacognition with insight problems compared to, say, mathematical problems, she found that with insight problems, the feeling that you're about to solve it, as she measured it every few seconds. For insight problems, you just go along thinking, I can solve it, I'm not no closer to solving it, and then all of a sudden I've solved it.
Right.
Whereas for mathematical problems, you're incrementally going up. I think I'm nearly there, I'm getting closer, I'm getting closer. And so some problems seem to lend themselves to that insight, if you like, that metacognitive understanding of whether or not you're going to solve it and how close you are to solving it. And I wondered whether there's what kind of variability there is in the problems that you've been looking at. Are some of the ones where people just don't have good judgments of solvability?
I'm going to give it eventually. We don't, these data are so new, we haven't dug into them on sort of an item analysis. But what we do know, like generally, not as an item by item thing, but generally speaking, people's confidence increases over an interval. So if you look at make them give an initial answer to the problem and then let them think about it, by the time they're done, they're more confident, even if the nothing has changed. And one thing that we think is, Lyndon was talking about this yesterday, is that people might be sort of building up their confidence, like the idea of, we've talked about rationalization versus, you know, actually changing your answer. Rationalization might serve the function of making you sufficiently confident to give the answer. And that's not quite the answer that you were looking for, but that's what I got data for, so. Gord, yeah, 1 minute.
Okay, go ahead. I'm going to try to attempt to weave three talks together in terms of some general theme here. Forgive me for doing so. What you said about cognitive inertia makes a lot of sense. Like people are kind of stuck on a thing, and that sort of explains how we will like persist on a project. Then there's no good reason to do so. If we think about Luke's work on imagination, and also the counterexample strategies that Henry was talking about. I mean, one aspect that's required is for some at some point during when they're working on a project, solving a problem, whatever, you have to do this kind of extra metacognitive thing where you think, what am I doing? And why am I doing it? Am I likely to be successful? And so in order to do that, you have to think about what's missing. Like, what is you have to kind of step yourself away from the actual process of what you're doing and like think about it above. And like that seems to me to be like kind of core individual difference. Maybe, right? Like that's the same sort of thing that I was talking about. And the thing that triggers it, I don't know, you're talking a lot about like what are the things, the features of the problem that trigger it. But it seems to be like a thing that some people, that varies a lot between people too.
Yeah, yeah, this is very synthetic.
I don't know how to link it all together.
Right.
Yeah,